Hey there, welcome to my channel, and for those of you who have already been here, welcome back to my channel. In this video, what we're going to do is determine whether a quadrilateral is a rectangle using properties of slope. Very specifically, what we're going to do to prove that this is a rectangle is show that opposite sides are parallel and adjacent sides are perpendicular. As a reminder, parallel lines have the same slope while perpendicular lines have slopes that are opposite reciprocals. All right, let's start by finding the slope of line segment AB. So for the numerator, we always subtract the y values, and for the denominator, we subtract the x values. So we're just going to look at the values inside the parentheses here. So what I'm going to do is start with this y value of -7 and subtract it with this y value of +2. And for the x values, we have to go back to the same point we started at the top. So we're going to take -6 and subtract that with -9. All right, so we're going to change these consecutive negatives here. And we get a numerator that's equal to -9. And on the bottom, we have +3. And that gives us a slope equal to -3. All right, let us go ahead and find the slope of line segment CD. Now, what we're trying to prove here is that these two line segments are parallel to each other. If they are, then we're going to get the same slope. So once again, we're going to subtract the y values on the top and the x values on the bottom. So going to points C and D here, we're going to start with this y, which is 7, and subtract that with this y, which is -2. And on the bottom, we're going to go to this x, which is 6, and subtract that with this x, which is 9. All right, so for the numerator, we get 7 plus 2, which is 9. And on the bottom, we get -3. And when simplifying, we do get the same slope as this line here, which is -3. All right, now what we have to do is find the slope of these longer sides here and see if they are opposite reciprocals of these numbers. So let's start with the slope of line segment AD. So looking at points A and D, we're going to subtract their y values, 7 and 2. So we have 7 minus 2. And then for the x values, we have 6 minus -9. And that would end up giving us 5 on the top, and on the bottom, that would end up giving us 15. And when we reduce this fraction, that is equal to 1/3, which is the opposite reciprocal of these two values. And now let us find the slope of line segment BC. So let us subtract the y values of those 2 points, which would be -2 and -7. And for the x's, we have 9 minus -6. All right, so we have -2 plus 7, which is 5. And on the bottom, we have 15, which is equal to 1/3. So as you can see, line segments AD and BC are parallel to each other because they have the same slope as our line segments AB and CD. They are parallel to each other because they have the same slope. We have also proven that these two line segments are perpendicular to these two line segments because their slopes are opposite reciprocals of each other. And by the way, one thing that is always true about lines that are perpendicular is if you take their two slopes and you multiply those two values together, what you will always get is -1. So that is what you are looking for when you are trying to prove that two lines are perpendicular to each other. Their two slopes would have a product of -1. All right, thanks for watching this video, and please make sure to like and subscribe for more math tutorials. Until next time, this is Shane Masonette with Masonette Math.
Hey, I just want to say thanks for checking out this math tutorial. Please don't forget to hit that subscription button and enable notifications so you can be informed as I upload new math tutorials to my math channel. Until next time, this is Shane Masonette with Masonette Math.